everyone, welcome to the new video. So in previous video we saw about pod, what are pods, how pods are created, and what are multi-container pods, and what are how can we create multi-containers pod. So in today's video we'll see about replica sets, replica controller or replication controller, and deployments. So without further ado, let's go. So why pods are not self-sufficient, or why we don't prefer pods? Because when you create a pod, and if you delete a pod, or if pod crashes, or if node dies, pod is gone. It won't try to create it again, which is like which we don't want in Kubernetes, because if something is down and Kubernetes tries to bring it up, okay, that's a self-healing property of Kubernetes, but pod does not do it on its own. That's why when we delete the pod, it stays down, it doesn't create it. Okay, so the problems were, if the pod crashes, it stays down. If the node dies, pod is gone. No automatic scaling, no rolling update, and no self-healing. So pods are ephemeral, and if production, we never manage pods directly, because though pods cannot help us. Okay? Because if anything, due to any reason, if the pod went down, it won't come up. And if we create another pod, the data is gone, everything is gone, because that pod is not the old one. Okay, so how Kubernetes work on the desired state versus a current state. So if I said that I want 3 replicas, and Kubernetes constantly keep a check that what is the current status, is the current status matching with the desired status? If it is not, it will try to create. Okay, so this is a control loop. Okay, so always Kubernetes keep a check that there is a desired state maintained, and if it is not, it will try to make it possible that it comes to that desired state. Okay, so it will try several ways to restart the pod and do self heal. Okay, so because of this control loop, replication controller was there, and it was a old way. Now replication controller is deprecated. So before, now we use Replicaset instead of replication controller. So if you are asked that what is the difference between replication controller and Replicaset, you can say that replication controller was used earlier, but now Replicasets are used, and the way in which we select, do the selection when we create replica sets or replication controller, there is a way to mention the selectors, which is different in replica set and different in replication controller. This is also one of the difference. So replication controller itself was, if one pod died, it will try to create new pod. Okay, so suppose this is an example of YAML, that API version will be v1, that is a Kubernetes API version. The kind will be the replication controller, because we are creating replication controller RC. The metadata will be the name. The specifications is like replicas will be 2, like 2 will be created. Selectors, so selectors we have to give the key and value. Okay, key and value we have to give. But in replica set, you will see there will be expression, then key, then value, then operator, and then value, that this key is present in this value, something like this we can also mention in replica set. Okay, but here we directly have to give key value. Okay, match labels, metadata, like this is the label we have to match. The app is in nginx. Okay, and specification of container. Now if we do, we'll see the replication, but replication controller is outdated. Now comes the replica set, which has replaced replication controller, and it supports set based selector. So what I said there, so this is a term set based selectors. They were just key and value, but here it is, there was equality based selector, but here it is set based selectors. Okay, more powerful label matching and used internally by deployments that we'll see. So this is a example of replica. So here is a example of ReplicaSet YAML. API version is apps v1. So this is again a API version. Kind is ReplicaSet, metadata. Then we'll see the specifications or the selectors. So as you can see, selectors are the set base. So we can mention more like matchLabels, app nginx, we can mention more, but this is a set based selector. It is more powerful base selection. Okay, so if we delete one pod, it will try to create another pod, and that is what self-healing is. So if a pod crashes, a pod is deleted, node fails, so replica set automatically creates new pod. So this is one of the Kubernetes biggest strength. Now what we actually use in real projects, we use the deployments, because we don't directly create replica set, we create deployments, and deployment manages replica sets. It provides rolling update, it provides supports rollback, it easy scaling, zero downtime updates. So there are so deployment we actually use, we don't actually create a YAML where we define replica set, because deployment itself manages replica set. It has following feature: it provides rolling update, like it whenever updates are done, it won't uh, make all the pods down. The pod will go down one by one. When one pod will come up, then another pod will go down, and when that will, then the next one. It supports rollback. If suppose we want to do the deployment, the current deployment is not working, we want to go to the previous one, we can roll back, because there is a history maintained. Okay, there is a limit to the history we can keep, but there is a history maintained and we can go back to the previous history. Zero downtime updates and easy scaling, we can do scaling of the deployments with the command. Okay, so that's why deployment is preferred. So architecture flow is that a user will create deployment, and in deployment will create a replica set, and replica set will create a pod. So this is how in actual real world project what we create. So in deployment we are going to our API version will be apps v1, kind will be deployment, metadata, specification, selectors. It is more similar like replica set, just that we need to give a define kind as deployment. Okay, the pods. Now if you do kubectl get deployments, kubectl get rs, or if you apply this and then run these command, you will get these answers. Okay, so if you want to see the demo, let's start. So suppose see, I've already done. If I did kubectl get pods, I got the pods, and you can see first of all kubectl get deployment. So there are my app, Netflix, nginx-lb, web app, and you can see the pods are double. So if there are two, so there are two pods created. If there are two replica sets. Okay, if I have to get replica sets, then see the desired state, current state. So whatever, as you can see that Kubernetes always try to follow the desired and the current state theory, and how many are ready and what is the age. And if you want to scale anything, kubectl scale. So if I want to suppose scale nginx1 scale. So now I want to scale nginx deployment. Currently it is 1. I want to scale it to 2. Okay, so the command is this kubectl scale deployment nginx, and one thing I have missed is hyphen hyphen replicas is equal to 2. So see, it is saying it has scale, and now we'll watch how if we do get pods hyphen hyphen watch, so we'll see that now see 10 seconds, in 10 seconds it has created one another pod of nginx, because I have scaled it to 2. And if I suppose do kubectl get deployment, so it should show me the 2. So there are 2 replicas, and that's why, and both are ready, that's why 2 by 2. So this is how. And if I do the what you say rs also, you will see there are 2 desired, 2 current, and 2 are the ready one. So this is one, you can say that without any without any downtime, you can see that it has scaled. Now if you want to see that how it also does the update without downtime, if I will change any the image, or you try to do it, just try to change the image, or the in the YAML file, the image you have, whatever image you have defined, just try to change the image and then apply it. What you will see, it will try to restart the pod one by one. So first the first pod will go down, it will, once it will come up, the next pod will go down. So this is how, that's why deployment is being used, because there are scaling properties, there are no zero downtime, and update with rollbacks are present, updates are present with no downtime. So that's why deployments are used in the real world. So yeah, that's all for today's video. That's all for today's video. I hope it's helpful. Please let me know your views in the comment section. Till then, take care. Bye.